when I give talks on robotics and robots, people, often worry whether, my work's going to build the Terminator. But Pat, I was pleased to see you were up front that you're building the Matrix, and going to enslave us that way rather than, So I'm going to talk about robots today, and my message is fairly straightforward. The US invented and led in manufacturing robots at one point, but then that got completely taken over by European and Japanese companies, and we lost our lead there. Right now, the US leads in a new class of robots for unstructured environments, and world demographics are going to be pulling on the need for these sorts of robots more and more over the next few years. Japan, Korea, and the EU have declared that they want to take the lead in these areas, so there's a race going on. And investment in research at the intersection of computation and robotics is going to be critical for us to continue to maintain the lead and make progress. So back in 1961, a company called Unimation, led by Joe Engelberger, installed the first industrial robot in a factory in New Jersey, a GM factory. But Unimation was later bought out by Westinghouse, and that was sold to Kawasaki, and now all the manufacturers are in Europe and Japan: KUKA, ABB, Yaskawa, Fanuc, etc. And those industrial robots of old didn't have much in the way of computers or sensors. They were expensive, so they basically worked by being able to do a motion very accurately and repeatedly for years on end. And so the cost of systems integration was the dominant thing there, because there wasn't much computation. So you had to make everything work so that repeatedly doing something was the right answer. And industrial robots are still much the same as that today. So in some sense, industrial robots aren't very interesting from a computer science point of view. My new company is trying to fix that, but I'm not going to talk about that today. What I do want to talk about is this new class of robots that we already have, that have already arrived. And some of us are old enough to remember when computers were like this. There were backroom operations. Ordinary people didn't get to touch them. There was a priesthood of engineers who got to touch them only. And then we let people start touching computers in the late 70s, early 80s, and all sorts of different devices proliferated and changed our lives, transformed our lives, as we've talked about today. So the robots in factories are much like those old mainframes. No, ordinary people can't touch them. One, they're too dangerous. You don't want to be near them. They'll kill you if you get in their way because they don't sense you. But what if ordinary people could touch robots? How would that change things? And the answer is that today they can. There's a new class of robots that have come about really just in the 21st century, where ordinary people touch the robots. The top left picture there is the intuitive surgical Da Vinci system. I don't know whether you call a surgeon an ordinary person. They certainly don't think of themselves as ordinary, but the surgeon is on the left there, teleoperating these devices, going through small openings in the person, laparoscopically doing surgery. On the upper right-hand corner are some of the cleaning robots from iRobot, from my company, and as Peter said, about 4 million of those have been delivered to US homes. Across the bottom are military robots. There were 0 ground robots in the US military in 2002. There are now 10,000. iRobot was involved with about 2,000 of them, and these are all examples of them. But notice the guy in the middle there. He's an ordinary soldier. A lot of the people who use these robots are actually 19-year-old kids who in Iraq, and they've never touched a robot before they get to Iraq, and they're given the robots that send them out after IEDs. So this guy came into a depot with his robot, Scooby, and you can see the back of Scooby's head there, just on the left, and you can see the chalk marks on there that he'd put on there. VBID, it had gone out on one vehicle-based device. On the right, UXO, one exploded ordnance, and in the middle, 17 IEDs, 17 improvised explosive devices. It had done that many missions, and then it got blown up, and this guy comes into the depot with his robot in a box saying, "Can you fix Scooby?" They said, "We'll give you another robot." He said, "No, I want Scooby." I've been a lot of places with Scooby. So ordinary people dealing with robots. And on the bottom right-hand corner there, you see future combat systems not yet deployed, but the idea is to have a robot with every troop of 9 soldiers in the US military in the next 3 years. So ordinary people now touching robots. So this has happened all this century, since 2002 really. And these robots rely on computation, sensing, perceptual algorithms, some of the things that Pat was saying are hard to do still, user interfaces, reasoning under uncertainty, machine learning, all the sorts of things we've seen today go into making these robots work. Now, do we need robots? You know, we've got a lot of people. Do we need more robots? Well, let's look at demographics for a second. This is Europe in 1950. Men on the left, women on the right, a histogram of age. And you see the age distribution of Europe in 1950. Now we go to 2000. Now we go to 2050. And you notice the snake swallowed something. It swallowed the baby boomers. And so here's the data for Japan, same format. It's even worse in Japan because Japan has no immigration, whereas Europe has some immigration. So, you know, we worry about Social Security not being paid for as there's more older guys like me and Ed and less younger people. But it's worse than that, there'll be less younger people to provide the services, so those services are going to get more expensive. So those Social Security dollars will not go as far even as they do today. So there's going to be more demand for increasing productivity in people doing sort of everyday work out in the world touching stuff. Not in the well, in the factories too, but just in everyday world out there where these new class of robots operate. Hereby, this is the US data, and it's not quite as bad as Europe because we do have more immigration. But you see this is 1950, and you see the baby boom just getting born at the bottom there, and then the baby boom moves through this over 100 years. And when we go out to 2050, the ratio of, say, the 65 to 69-year-olds relative to any younger cohort is, you know, just a little less than 1, whereas back in 1950, it was a ratio of 3 or 4 to 1. So very different age profile. Here's another presentation. The red line is the percentage of the US population above 65, and we're just about to go on that hockey curve right there. We're just, as the baby boomers start to retire. So a big increase in number of older people. Now, I'm saying that this is going to lead to competition for labor. Is that true? Well, you know, it's starting to happen in some places. We see it. Filipino nurses, for instance, are in great competition to get them to emigrate to places. This is Australia, where I'm from originally. Rio Tinto, second biggest mining company in the world, second biggest in Australia. They're both in Australia. And they've decided, this is January 2008, they're going to replace humans with robots in their Western Australian mining operations because the conditions out there are just lousy. People don't want to live out there. So they're trying to robotify it. They're putting a lot of money actually into research at Sydney University, into computer science and robotics there to push that. That's January of 2008. Here's a story from the same newspaper in March of 2008. Half of Australia's submarine fleet, only half of Australia's submarine fleet can be sent to war because of a critical shortage of qualified submariners. Well, what happened to them? Well, they all got bought out by the mining industry in Western Australia because these were technically competent people who didn't mind living in lousy conditions. So you see the competition starting to happen, and there's lots of this all around. Now, Japan, Korea, and the European Union have all said they want to get a piece of this new sort of robotics, and they want to be they more than want to get a piece, they want to be the leaders. So this is Ministry of Economics, Trade and Industry in Japan, fostering the robot industry to become a new world-leading industry. Korea, trying to put a robot in every household between 2015 and 2020, and there are now currently 15 Korean domestic robot companies building home cleaning robots. They will get out of Korea in the not too distant future. The European Union under Framework 7, Framework 6 and Framework 7, lots and lots of robotic programs. I just put together 108 projects here for one of those EU programs. But actually, quite a few of these robots were built in the US, taken to Europe and being reprogrammed there as part of the research. So there's a lot of competition out there, a lot of putting research money to try and become leaders of this new industry. My last piece of the message is investment in research at the intersection of computation and robotics is critical for success, and I want to explain that a little bit just by talking about the classes of robots we have out there and talk about autonomy. What is autonomy? What do I mean by autonomy? Well, autonomy is a spectrum of how much a human is involved in controlling a robot, from pure teleoperation on the left there to total autonomy on the right. And let me define those things. In pure teleoperation, there's a person involved with a joystick controlling the motion of each motor at all times. They're really controlling it. By the time you get to supervisory, and so you want to get a robot from place A to place B, you've got a joystick and the person controlling the motors with the joystick to drive it. When you get to supervisory teleoperation, a person might just specify a gross motion, say, go in a straight line, and then local intelligence deals with adjusting the motors so the robot goes in a straight line. At the task level autonomy, you might say, here's a map, go to this place, and then that place, and then that place over there, deal with the details, and the robot does with the details. And finally, you get to total autonomy, where you just send the robot off, and it chooses its mission, it does what it thinks is right in the circumstances. Now, we've had this various levels of autonomy creeping into many of our devices. Again, for those of us who are older, might remember this sort of automobile. That was pretty much pure teleoperation. There's a person in every control loop in there. When you get to a more modern car, though, with an anti-lock brake system, you give a supervisory control. You say, I want to stop real fast. But that's not saying I want to apply the brakes hard on. The system decides how hard to apply the brakes and when. And I just saw an ad this weekend for a new Volvo, where it said it will stop if it's about to run into something. So there's a collision stopping coming up. And airplanes, although pilots don't always like to admit this, are almost near task level autonomy, where you can say go from here to there, and the airplane takes care of, the autopilot takes care of most of the flying. And then you get to total autonomy, where you send off your system through time and space, and it does whatever is necessary. Now, one would think, okay, autonomous, that's harder to make robots autonomous, so they should cost more. So the rational expectation should be that this cost curve would look something like that, okay? But in fact, if you look at the robots out there, the cheaper they are, the more autonomous they are. This doesn't seem to make sense on the surface. What's going on? Well, if we look at say, Japanese robots, the famous Honda robot is almost all teleoperated because it's got to put on a good show every time. By the time you get up to the cheap Sony Aibos playing soccer programmed by university teams around the world, the goal is to make them autonomous, and they're cheap. If we look in space, in the US, space robots, the space station is teleoperation control for the arm. The astronauts move each joint around and get very good at it. When we had the first Sojourner, the first rover on Mars, it was much more like task-level autonomy, especially because of the 24-hour delay in getting to send commands to it. So you had to say, go do a few things and tell me about it tomorrow when I connect to you again. Now, the current Mars rovers on the bottom, well, first, the rovers in 1997, that was a $25 million add-on program to an existing mission. The current Mars rovers were a whole mission by themselves, very expensive, couldn't afford to have them fail. So when they first arrived at Mars, they were less autonomous than the 1997 ones. And the mission was supposed to last 90 days, and that was fine. They uplinked commands every day, but those damn rovers are still there after 5 years. The team that was on a 24-hour, 37-minute daily cycle has sort of got tired of controlling these robots. So over time, they've been uplinking more and more autonomy to the robots, and now they're able to do a lot more than they were when they originally got there, just because people can't be bothered controlling them so much. So same in iRobots, the military robots are more teleoperated, the cleaning robots are more autonomous. And really why this is because it's not worth a person's time to operate a cheap robot. So you got to make it autonomous for it to be useful. And in a must-succeed situations, it's too risky not to have a person overseeing the robot. But if we really want robots to help with this labor shortage that we're facing, the robots better be more autonomous. They better succeed more of the time. So our robots have to get better at succeeding. So we're going to need more ways to make them more reliable, ways to make them understand their world better. The DARPA Urban Grand Challenge, many of you know about from 2007, had a bunch of autonomous robots driving around for 6 hours in traffic. The leading teams were all university-led, and they had industry associated with them, but they were pulled together by universities. And the robots were able to operate for 6 hours without collision. In the middle on the right there, I just found this photo on the DARPA website. It's just fantastic. There was a mounted horse guard at the Urban Grand Challenge. And this is great for 2 reasons. Probably none of us remember the start of the Second World War, but at the start of the Second World War, there was a big argument in the US military over whether the cavalry was still important. And some people thought the cavalry is still important. And then armored vehicles overtook them very quickly. We're seeing that same sort of thing right now in unmanned air vehicles. Do you need a real pilot to fly an unmanned air vehicle from Las Vegas, or could it be someone who's just trained in operating, not being a real pilot, to fly that remote vehicle? I think it's much the same as the horse argument. But the other great thing about this is the horses have a great user interface. They're very much a supervisory teleoperation. You tell them where to go. You don't have to tell them where to place their feet. They've got intelligence, and it's symbiosis between person and vehicle, horse vehicle in this case. And I think that's what our robots will be more like in the future. In future combat systems, we see a lot of robots coming online. Some of them are supervisory teleoperated. Some of them could be upgraded to navigation autonomy with more research on how to do it, and the existing hardware platforms that are going to get delivered. So the research challenges to getting more autonomous robots are better visual object recognition, understanding social context. If our robot's going to interact with us, they have to understand who people are, what their interactions mean, and be part of that. Understanding of spoken language and sound more generally, better than we can do. New sensors. And in order to do more things, we also have to get our robots to manipulate objects. Because if these are going to be the replacement workers in our service worlds, they have to be able to go in and touch stuff and do stuff with their hands. And then better networking, both physical and virtual ad hoc groups, and so on. The CCC has been developing a roadmap on robotics, and you can go there and see how this might play out in manufacturing, medical and healthcare, and service industries. So thank you for your attention.